Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on October 11th, 2025, about 5 days ago. The big hook is ECHO, a prompting framework that turns failed interactions into synthetic successes and boosts sample efficiency with gains up to 80% over a vanilla language agent baseline. The paper is titled Sample Efficient Online Learning in LM Agents via Hindsight Trajectory Rewriting. And as we will see later, the implications for online adaptation are quite significant. This paper evaluates stateful navigation and enterprise Q&A settings, showing faster learning and competitive efficiency. Alright, the previous segment introduced the core idea. Figure 1 shows a failed run in XMiniGrid on the left, where the agent misses the orange star but still explores useful rooms. The right side contrasts responses. Reflection writes a generic note. Her and AWM record no update, while ECHO proposes alternative goals and concise workflows, which the agent can reuse. This matters because those counterfactual workflows transform a failure into actionable guidance for future queries. So the previous figure contrasted agent behaviors. Listing 1 presents the core ECHO loop, which first applies a hindsight rule that summarizes the trajectory, identifies attainable goals, and synthesizes optimized workflows the agent could execute. The lower block then runs an update rule that keeps a replay buffer, replacing any existing workflow for a goal only if a shorter description exists, which promotes concise, reusable plans. This compression matters because shorter workflows generalize more reliably. Alright, listing 1 set up the loop. Figure 2 reports how that loop translates into gains in XMiniGrid. The figure presents 2 panels summarizing mean reward and cumulative improvement across episodes. The left panel shows bar charts where ECHO reaches about 0.27 mean reward, topping React, Reflection, AWM, and AWM++, which indicates stronger sample efficiency. The right panel plots cumulative average reward gain, and the purple ECHO curve surpasses the baseline after roughly 3 interactions and keeps climbing as episodes continue. Okay. The previous figure reported gains in XMiniGrid. Figure 3 compares methods on PeopleJoinQA. The left panel reports accuracy in messages per method, while the right panel plots messages saved over episodes. Reflection posts the best accuracy, about 59%, but AWM and ECHO cut roughly 1.6 messages per query. The right plot shows ECHO surpassing React after the first query and maintaining a steady efficiency lead. Well, the previous figure contrasted accuracy and efficiency on PeopleJoinQA. This table specifies the LM summarize prompt that powers the hindsight rule, which asks the model to compress a trajectory into high-level steps. The header frames the task as creating a concise, high-level summary. The include and exclude lists direct the model to group actions, list all discovered objects, and omit step-by-step moves. The output format block enforces chronological entries so memories stay structured and reusable. So, the previous figure detailed the summarize prompt. Table 1 lists the React hyperparameters, which fix decoding to be deterministic and keep comparisons fair. The temperature is 0, so the agent produces repeatable actions given the same history. The max new tokens is 4000, which supports long stateful episodes without truncation. The API version is 05-13, indicating the exact runtime used for the XMiniGrid agent. So, the previous table fixed the decoding settings. Figure 4 compares methods across 5 PeopleJoin organizations, plotting % accuracy gain and queries saved over episodes. The panels show that performance depends on the organization, which means no single approach dominates both accuracy and efficiency. In the department store setting, the right panel shows ECHO surpassing React in efficiency after roughly 15 queries. Reflection often leads accuracy, while AWM sometimes saves the most messages. Alright, 2 takeaways stand out. First, ECHO turns failed episodes into concise, counterfactual workflows, which makes online learning far more sample efficient, with gains up to about 80% in grid worlds. Second, the approach suggests broader promise for agents that must learn under costly, partially observed interactions. That is it for the AI Research Roundup. I am Alex. Thanks for listening.